Hello students, in the previous video I explained about the formation of interhalogen compounds and the different types of interhalogen compounds. In that I explained to you what is interhalogen compounds. What is the meaning of interhalogen compounds? When one halogen is combined with other halogen to form a compound. When you will write, you have to write in a correct way. One halogen is combined with other halogen to form a new compound that is called as interhalogen compounds. But at the same time you have to remember it, what are the different characteristics of the interhalogen compounds. In the interhalogen compounds, the central atom should be larger in size. Okay, whereas fluorine among all the halogens, that is the smallest one, so it cannot be a central atom. At the same time, due to the high electronegativity and smaller size of fluorine atom, it helps the central atom to attain high coordination number. And third character, interhalogen compounds always it is formed in between two halogens only. More than two halogens it never be formed. In between two halogens only it will be formed. Okay. And last one, all the interhalogen compounds are strong oxidizing agent. I set four characters. What are they? One is all the interhalogen compounds are strong oxidizing agent. In the interhalogen compound, the central atom will be larger in size. Due to the smaller size of fluorine, it can't be form a central atom. And next one, fluorine can't be act as a central metal atom, I said. Then due to high electronegativity and smaller size of fluorine, it helps the central atom to attain high coordination number. And the interhalogen compounds, it will be formed in between two halogens only. Okay. And next, let us see, so what are the general oxidation number and the number of, what is the structure and everything we are going to see. Here you see the different types of, look at this tabular column here, AX type, AX3, AX5 and AX7 is given. AX, that is a linear in shape, and the type of hybridization is sp3, and the bonded pair of electrons are 1 and the lone pair of electrons are 3. And AX3, so that is a T-shaped one, and the hybridization is sp3d, and the number of bonded pair of electrons are 3 and lone pair of electrons are 2. At the same time, AX5, square pyramidal in shape, sp3 d2 type of hybridization involves 5 bonded pair of electrons are present and 1 lone pair of electron is present. You can see very well the number of lone pair of electrons are going on decreasing. Okay, and bonded pair of electrons are going on increasing when the type is increases. AX, AX3, AX5, AX7. That is pentagonal bipyramidal in shape, and the type of hybridization involves is sp3d3. sp3 in AX, sp3d in AX3, sp3d2. You have to add 1 orbital slowly, and sp3d3. So here the bonded pair of electrons are 7. There is no lone pair of electrons. Okay, it's very, very important one. And now let us see how the oxides of halogens are formed. Oxides of halogens. Look at this tabular column. So here the oxides of halogens are given. X2O, XO2, XO3, X3O6, X2O7. So here the X, it represents the halogens. So in these all the oxides, fluorine it shows only, already you studied in 11th standard, fluorine is only one element, it shows only -1 oxidation state. It cannot shows other oxidation state. So therefore, when fluorine is combined with oxygen, it forms OF2, O2F2 and O4F2. In all these three oxides, you can see the oxidation state of fluorine, that is -1 only. Whereas chlorine, it shows different oxidation state, +1, +4, +6 and also +7 and -1 oxides. So in the +1 it shows Cl2O, and in +4 it forms ClO2, and in +6 Cl2O6 and Cl2O7. In this way it forms different types of oxides. Okay, And another one, that is the bromine and iodine also. It shows a different oxidation state. In +1 it forms Br2O, and in +4 it forms BrO2. And iodine, it shows only in +5 it forms I2O5, as well as -1 also it forms I2O4. Okay, so this is the oxides of what? The halogens. Next one is the oxo acids of halogens. Oxo acids of halogen, it is classified into 4 types: hypochlorous acid, halous acid, and halic acid, and perhalic acid. There are 4 types of acids are there here. That is the oxo acid. What is the difference between oxides and oxo acids? Oxo acid, it carries hydrogen, oxygen, and halogen. Oxides, it has only oxygen and halogen. So here the oxidizing power of oxo acids are given. HOX is greater than HXO3, and that is greater than HXO. O2 is greater than O3, then that is greater than HXO4. HOX is hypochlorous acid, O2 is halous acid, and halic acid is HXO3, and HXO4 is perhalic acid. So here so in among these all the 4 type of oxo acids, fluorine, it forms only hypohalous acid. Okay, so that is the one word. And chlorine, it forms all the 4 types of acids, oxo acids, and bromine, it forms the hypohalous except halous acid. Remaining all the acids will be formed by bromine. And iodine also, it forms except halous acid, hypohalous acid, halic acid, and perhalic acids are formed. Okay, now let us see the reactions, how the interhalogen compounds it reacts with alkali. Interhalogen compounds, when it reacts with an alkali, the larger halogen it converts into oxyhalogens, and smaller one it converts into halides. This is the principle, basic principle, otherwise basic concepts involved in this reaction. When the interhalogen compounds, it undergoes reaction with an alkali, the larger size of the halogen it converts into oxyhalogens, and smaller one it converts into halides. So here two examples are given. BrFi. So BrFi, as you know very well, fluorine is the smallest one and bromine is the larger one. So fluorine, it converts into what? Halides, fluoride ions, and bromine, it converts into what? Oxyhalogen, BrO3 minus. Similarly ICl. So if you are comparing iodine and chlorine is smaller in size and iodine is larger in size. So iodine converts into oxyhalogens and chlorine converts into chloride ions. Okay, and next one is what? The noble gases. The noble gases, let us see what is the meaning of noble gases. 18th group elements are called as what? Noble gases. 18th group elements are called as noble gases, because in the 18th group, helium, neon, argon, krypton, and xenon, these are the elements are present. These noble gases are also called as inert gases and rare gases. Rare gases means it occurs on the earth crust in very less percentage, therefore it is called as what? The rare gases. So why it is called as the inert gas? Even though these are highly inert means it's not showing any reactivity, but krypton and xenon, among the noble gases, its reactivity is proved in the laboratory. Therefore, it is called as what? The inert gases. So let us compare the size as well as the ionization energy, boiling temperature of the noble gases. Here, the atomic size you can see. So slowly the atomic size is going on increasing from neon to radon. Similarly, the electronic configuration, that is the general electronic configuration, is ns2 np6. Even in all the cases, the outermost shell configuration is what? 2s2 2p6 for neon, and for argon, since it belongs to the third period, so 3s2 3p6, and krypton, it belongs to the fourth period, therefore 4s2 4p6 is the outermost configuration, and xenon, it belongs to fifth period, so its configuration is 5s2 5p6. And at the atomic size, slowly it's going on increases, and melting temperature also slowly it increases from neon to radon. Boiling temperature also it's going on increases. Okay, so now let us see some reactivity of the krypton and xenon. Xenon, when it reacts with the fluorine at the temperature of 400 degrees Celsius, it gives XeF2. Xenon, it reacts with 2 moles of fluorine at the temperature of 400 degrees Celsius. In the presence of nickel and acetone as the catalyst, it forms xenon tetrafluoride. Xenon tetrafluoride, the molecular formula is XeF4. And xenon, when it reacts with 3 moles of fluorine at the temperature of 400 degrees Celsius, in the presence of nickel, and the atmospheric pressure is maintained at 200, and then it changes into XeF6, that is xenon hexafluoride will be formed. So among the difluoride and tetrafluoride and hexafluoride of the fluorine, the hexafluoride again it shows somewhat reactivity. You can see that hexafluoride, xenon hexafluoride, when it undergoes hydrolysis, it gives XeO3, xenon trioxide, and hydrogen fluoride will be formed. Xenon hexafluoride, when it is treated with sodium hydroxide, it gives one important oxidizing agent, that is called a sodium persanate. This is a 2-mark question. So sodium persanate, how it is prepared? When xenon hexafluoride is treated with an alkali, sodium hydroxide, it forms a strong oxidizing agent of the sodium xenon xenate. So for that, how do you prove the oxidizing nature of sodium perxenate? So here the equation is given. The equation is given in ionic form. Okay. So in the presence of acidified potassium permanganate, otherwise manganese dioxide, so there is this reaction, oxidizing reaction takes place, and this is the ionic equation. Similarly, krypton, when it reacts with fluorine, if these two gases are passing through an electric discharge at the temperature of 183 degrees Celsius, it gives krypton difluoride. Krypton difluoride, when it is treated with antimony pentafluoride, then it forms an additional product of KrF2 with 2 moles of SbF3. Okay, so this is the reaction of krypton with fluorine. So previously I explained about the reaction between helium and fluorine, xenon and fluorine, and this is the krypton with fluorine. These are the reactions. Okay. Similarly, when xenon hexafluoride, it reacts with the silicon dioxide at the temperature of 50 degrees Celsius, it gives XeOF4. So on further treatment with SiO2, it gives XeO2F2. And then again on further reaction with SiO2, it gives xenon trioxide. So here xenon trioxide, 2 methods are given. How do you prepare xenon trioxide from the xenon hexafluoride? This is the long process method, and this is what short method. Okay, so that's all.